What's up? Nick, aka Sporp here. Remember that one episode of How I Met Your Mother when Lily and Marshall moved into that apartment with that ridiculous slant? I used to think that was hilarious, but completely unrealistic. And then I moved into this apartment. This is under my desk, and this is a rope. I need this rope to tie my chair to my desk, or else this will happen. Fuck this apartment. So I've been using a couple different tricks to try to level out this apartment to the best I can. So you saw the rope one, but I've also been using paper for under a couple different pieces of furniture. But for the really big gaps, I've been 3D modeling and 3D printing some functional parts. So this here is one of the first parts that I actually 3D printed for this apartment. Now, I've been 3D modeling and printing for about the past 6 years now, so I know a thing or two, and I'm going to walk you through sort of my process for making a functional print like this. This guy is a cube cut out of a cube. Most of my 3D modeling happens through this one program called Openscad. We're going to get more into that later. So I messed up the dimensions slightly, and that's why it kind of looks gross in the back here. I had to cut away a little bit of the plastic with a knife so that it would fit the dimensions of this square leg here. When modeling something for real life, you really want your dimensions to be close, but leave a little bit of room for error. So you want to make your print slightly larger if you want something to fit inside of it, and slightly smaller if you want your print to fit inside of something. The usual recommendation for this room for error, which is called tolerance, is about 2 millimeters. Another thing you gotta take into account when figuring out these dimensions is something called shrinkage. Male viewers may have a little bit more experience with this than others in this concept. The printer prints things nearly to the exact dimensions you give it, but as your print cools, it will ever so slightly shrink in size. When solids are heated up, they tend to grow, and when they get colder, they shrink. We're printing this plastic here at about 400 degrees Fahrenheit, so by the time it's back down to room temp, your print may have shrank up to 1% in scale. Get a little tolerance so it doesn't look like this. Oh god. And this is the other piece that I printed. This is a cube with a cylinder cut out of it to fit this wheel here. Let me show you this one. So we back this up a little bit. It's a cube, and there's a cylinder that matches the radius. The radius of this cylinder matches the radius of this wheel. So those are some of the models that I've made to level out this bar cart here. But the next piece on the list is I need to level out this stove. Nick and Stove is filmed in front of nobody. Hey, you stove.
Hi, Nick.
Aw, you sound a little down in the dumps. What's wrong?
I'm not doing so hot. I feel unbalanced. Things keep sliding off me.
Well, that's just no good. We'll fix you up right quick in a jiffy.
Oh, that's sweet. Also, could you feed me the tortoise?
Later. Shh. So, I'm going to use similar methods that I used to level out the bar cart here in order to level out this stove. I originally took some cardboard from the packaging that the stove came in, and I put it under this foot here, which actually just fell out as I was removing the cardboard. Now, I know what you're thinking. Nick, why on earth would you use cardboard to level something out right next to the oven's heating element? Now that's a pretty easy question to answer. Number one, I'm lazy, and number two, if this place burned to the ground, I could use the insurance money to live in an apartment that didn't have the slant of a goddamn pinball machine. Basically, I'm gonna take this thing and model an additional foot to put on top of it. You can see that some of the plastic is already peened over. Why on earth anyone would use plastic as a leveling foot for an oven is beyond me, but hey, we're gonna make a plastic foot for this plastic foot. So, to level this thing out, I'm going to use pretty much 3 different tools. 2 if you don't really count the pen and paper. So the pen and paper, a level, which is a way of how I'm going to see how much this oven needs to be raised so that it is level against the floor. and a pair of calipers. If you want to get started 3D modeling, I absolutely recommend getting a pair of calipers. For the dimensional accuracy of 3D models, these things are a godsend. For years, I used to eyeball distances with a ruler, and my prints never came out to the right size. I put a link to the pair that I have in the description. They're nothing to write home about, but they get the job done. If you're starting with any hobby, don't get the expensive stuff first and think you'll grow into it. Get the cheap stuff first to make sure you actually like it. These ain't no me tutorials, but they're good enough. First things first, I'm gonna use these calipers to see how big my inner lip for my new foot needs to be. So this is across on the hexagon. It is, if I actually can use the caliper as a reference here because that's a straight line, it is around 40 millimeters end to end. Now that I figured out that the largest diameter of this hexagon is 40 millimeters, I can start designing my model to accommodate it. So I'm going to have an inner sort of divot in my print that is 40 millimeters across, plus the tolerance so that this piece will actually fit inside of here. So I'm going to bump that up to 42 millimeters on the diameter. Okay, so that's 42 millimeters across. Then I'm going to add a 2 millimeter lip to go around it, like so. The last measurement I need to figure out here is this drop measurement of this cylinder, because this is going to essentially be one cylinder to lift this up, and then a little cylinder cut out of the top so that this foot has something to fit into. So the last measurement I need is this here. And to figure that out, I'm going to use a level. Now this won't necessarily be easy since my girlfriend is not present at the moment. I'm going to have to figure out all this shit on my own. What I need to do, I'm going to use this level here. See it? Pretty. Ooh. I'm going to use this little bubble inside to see how far I need to lift up my stove until it is level. And since it's bowing down in that direction, I'm going to sort of point the level that way because that's the way that I want to level it out. I will then push this until the bubble is completely between the two lines, and then I will figure out the gap. I'm going to try to brace as much as I can without having to lift so I don't throw out my back. That is about 35, 36 millimeters. And the good thing is, since this actually has some travel on it, I only really need to boost this up probably 30 millimeters. And then I can just use this foot and twist it to get this in the right shape. So what I'm now going to do is I'm going to go into Openscad. I'm going to make the dimensions of everything that I need, and then since I'm recording it, I'll just give a quick walkthrough. This is dead simple, so this shouldn't take very long. So first things first, I will make 2 cylinders. The height of the first one will be, so we settled on 32, and the diameter will be 44. And then the second one, remember I said 2 millimeters of tolerance, so I kind of want this to be even larger than that. I'm going to make this one 40. And then I'm going to make another cylinder with a height. Height doesn't necessarily matter because this one will be deleted from the other one. And a diameter of 42, which is another one that we decided. Okay, so I make these. And we have our 2 cylinders. They look fine, but one's on top of the other. So now we're going to have to do a little bit of difference between the two. So if I do this, check this out. I render it, and now we're getting there. We see that we've now chopped out the small cylinder from the big cylinder, but I only want a little bit of chop out. So what I'm going to do is I will translate this guy up to the distance required. So 0, 0, and then the Z direction, which is, vertical. I will translate that up 32, which is how much we wanted. And there we go. That's it. I'm actually gonna bump up the wall thickness to 4 millimeters just to give this a little extra breathing room, but that is our foot. I mean, I could do a couple different things with it. If I wanted these to be hexagonal, I can do this cache FN function, and I can pump in a 6, and this reduces the number of polygons each of the sides have. I think that actually looks a little bit nicer. I might go with this instead. Yeah, 42, height of 40. This only really needs to be 36, I think. Yeah, that should work. Okay, done. So I will save this as, drop that in. I'm gonna call this oven foot. It's a terrible disease. So this is rendered. Now I can go over to Flash Print, which is the printing software that my printer comes with. So I will then find my STL file, which I made, oven foot, drop that in, and there we go. That's about it. I will then punch this into an SD card. I will print it, and then I should see you in a little while. This is my 3D printer. It is a FlashForge Creator Pro. It's a dual extruding printer. Do I recommend this? No, you can save so much money by getting a single extrusion printer. The only reason I ever alternate between extrusion nozzles is if one clogs, I just move over to the other one. That doesn't happen so much anymore since I did a full metal hot end replacement on this guy. Another modification I did is I increased the nozzle size from a 0.4 millimeter nozzle to a 0.8 millimeter nozzle. Since I doubled the nozzle size, I can double the amount of plastic that I flow, which means I can print my prints twice as fast. They're not quite as pretty, however, I don't really care. 3D printing works by a process called additive manufacturing. If you think of a marble slab that a statue's carved out of, it is the exact opposite way of manufacture. With subtractive manufacturing, all of your product material is there, you just have to chip away the excess. Additive manufacturing, nothing's there, and you build your entire product, start to finish, from nothing, essentially. The way that 3D printing works is that we raise the build plate up to the nozzle but leave a tiny little gap, which is the space where the plastic prints. We print an incredibly thin cross-section of our 3D model, and when then that cross-section is done, we lower the build plate slightly, and then we draw the next cross-section. It's just adding together little fractions of your final product to get to your final product. 3D printing uses something called filament, which is a thin string of plastic, typically 1.75 millimeters in diameter. It heats up the filament to around 400 degrees Fahrenheit, which is about 200 degrees Celsius, so it reaches its melting point. Then it cools back down to room temperature, becoming a solid again. Now, how does the 3D printer know what to print? Well, first we designed the 3D model on my computer, and then we ran the 3D model through something called a splicer. The splicer digests the 3D model and converts it into a series of machine instructions that the 3D printer knows how to follow. And that's it. I will see you in 45 minutes, and then we're going to install this foot together. And just like that, we're done. We got an oven foot to balance out our oven. Only took about 45 minutes to print, and then you gotta rip it off the print bed. Always a little bit of hassle, especially with PETG plastic. Then you can walk it on over to the oven, stick it on underneath, and raise that puppy up to the height God intended. And then you're done, and you can enjoy that oven the way it was made. I'd like to thank you for going along this here journey with me. I hope it was as enlightening for you as it was fun for me. That's even more level than I was trying to get it at previously, so nice. In every which way it's level. And now we can enjoy this stove for the remaining... Oh, we're so out of focus. We can enjoy the stove for like the 1 or 2 weeks we're remaining here.
You're nice.
Yeah.
Well, he's nice.
I'm okay.
I didn't do anything. But he leveled our stove.
Yes, I did. And our dog's barking!
Come here, Barky! Who's a good Barky?
Hell yeah. Should have done this a year ago. Or a year and a half ago.
Stop digging.
Now, if any of this stuff tickles your fancy, might I suggest picking yourself up a pair of calipers in the link in the description. I can think of worse ways to spend $20. I suggest picking one up. They're fun to mess around with. If you don't got 2 pennies to rub together, that's alright too. You can try out Openscad, our 3D modeling program, for free. Instead of tickling in your piggy bank and seeing what coins fall out, you can tickle the keys of your keyboard and make some 3D models. Oh, and if you're worried about this thing collapsing on me, don't worry. I tested it myself. With myself. Have a good day.